Hello everyone. So let's start solving today's Leetcode daily challenge question. So the question is find all possible stable binary arrays too. So it is the same question which we solved yesterday. If you see, question is almost same, but the constraint has changed. So if you see this part one, okay, or the first question is constraint is still 1 to 200, but if you see the today's question, constraint has changed to 1000. So if you submit the same solution, of course you will get TLE. Now we have to optimize this solution. So how we are going to do that is first you watch the previous video to understand this solution, how we solve this question, then come to this video. We will just optimize here. I'm not going to explain the whole thing. I'll just give a overview what we did. Now the question was we were given the zero number of zeros, number of ones, so we have to build a binary string, a binary array, sorry, binary array such that it contains zero number of zeros, one number of ones. So if I have 0 2 and 1 is 3, then I should have two zeros and three ones in my binary array. Now this is the first condition. Then what is the third condition is my subarray of a binary array of size greater than limit must contain both 0 and 1. So what we understood is if I have, let's say this example, if my subarray, my limit is 2, so greater than 2, that means what? 3. From size 3 to we have 5, so 3 to 5. Okay, subarray should contain both 0 and 1. That means we don't want consecutive ones or zeros greater than limit. Okay, so from where we can get is from length 1 to length limit. Okay, though from 1 to limit we can use these many consecutive in our binary array. So if my limit is 2 and my zeros are also 2, how like what I can use? I can use 0 once or I can use 0 two times. Okay, I can use once or 0 two times I can use. If my limit is, let's say my limit is 4 and my number of zeros are 5, so what are the possibility I can use? I can use 1, I can use twice, I can use 3, I can use 4 times, but I cannot use 5 times at a single time because greater than this limit subarray. So what is the subarray size greater than 4 will be first is 5, 6, whatever the, like if my number of ones are more than 2, it will be 5, 6, 7. So my 5 length, if I have this in my binary array consecutively, then this will not be our stable string. So what we have decided is, what we were doing is we were checking from 1 to limit, we will append this 0 or 1, and then that we will get the binary array, stable binary array. So here what we did previously, if we have written a recursive function where we are using the memoization. So if you see, initially we initialize the deep one 3D array we have taken, and solve. This is the recursive function where we are passing 0 1 limit and false. What does false means is was 1 last. So have we started from 0 or 1? So if we are starting from 0, okay, then what we have to write was 1 last, we have to write as yes, true. Then now we'll consider 0 as our starting point, else 1. Okay, later it will be changed. Then what we were doing this thing, so we have to understand it this properly. We are going to optimize this. Okay, now if we are going to optimize this, we should understand what exactly here we are doing. So from 1 to limit. So why I was saying limit is, okay, zeros left can be, if you see the constraint, okay, it is not here given that our limit will be always greater than this 0 or 1. So my 0 can also be less than limit. My limit can be 4, but my number of zeros are only 2, so I'll only check from 1 to length 1 to 2. Okay, so here what we are doing is solve zeros left minus I, ones left, limit false. So basically in recursive function, let's go to the next page. What we are doing is from, let's say my zeros left is z minus 1, 1's left, this is not 0, this is o, limit false. Okay, plus, so what we are doing, plus z minus 2, 0, this z minus 3, z minus limit. Okay, so what we are doing, we are doing the plus of all this. Now here if you see, from 1, why I'm saying I, we are doing minus I, right? So zeros left minus 1, next zeros left minus 2, so we are doing every time addition. It's basically what it is, a range sum. Okay, now how we can optimize this is, why can't we have the prefix? We can use the prefix concept here. Okay, so if you see z minus 1, z minus 2, so if I am able to calculate z minus 1, okay, I, if I am able to calculate z minus 2, then I can also calculate z minus 1. I can calculate like 1 with previous. If you are aware what is the prefix concept, let's say for example you have an array of a, b, c, d, e, f. Okay, these are numbers I have just taken as a, b, c, d, e. These are numbers, and what will be your prefix sum array? It will be a plus b, a plus b plus c, a plus b plus c plus d, and so on. Okay, so if you see here, what is this? Repetitive. Okay, so we will be storing a, now we will add 1 plus. Okay, so we will use previous sum with the current sum. So what here, what we will use is prefix of I will be prefix of I minus 1 plus current, let's say nums of I. Okay, this is what the general prefix sum, how we calculate. So similarly here also we can we calculate, if we calculate this every time, we don't have to calculate. Okay, so what we can do is, let's say my number of zeros left, initially it was 5 and 1, this is zeros left and ones left. Now again I have 6 and 1. So in that case, for 5 and 1, what I will be doing here, 4, 1, and this 3, 1, this 2, 1, this. What is this? This is the recursive call. Okay, solve function. And for 6, 1, it will be 5, 1, and 4, 1. Every time we are calculating plus. So if you have this 5 and 1, if we calculate and store somewhere, it will be easy for, like, we are doing the repetitive work. Okay, and if we want, let's say if we want only the sum between this and this, okay, if my limit is also less, okay, then we can find it, right? We want the sum of this and this. So if we calculate and store initially and then we can use later, that will be more helpful. Okay, now what we are going to do is, what will be my prefix. So if we are calculating prefix, so what we will do is prefix of Z and O. So we will, what we will do, we will use two arrays. One will be for this 0 and one will be for 1. Because as we have seen before, that if my previous last was 0, then the current was 1. So here also if you see, if and else, if was 1 last, then we'll considering the 0, else we are considering the 1. So he, in this case, for storing this thing we will use a different array, and for this we will use a different array. Now we can start. Before that, what I was showing is, it will be what, it will be prefix of 0. It's not in, okay, instead of this, what I'll write, my result. Okay, consider my result will be here My result will be prefix of z minus 1 of o minus prefix of, it will be z minus limit and o. Okay, so here we have to consider, of course, why z minus 1, because that is the greater number and this is the smaller number. So if we calculate the prefix to find between these two, what we use normally is, let's say we have r and l. R is the right and L is the left. So what we usually use is P of, let's say, current is equal to P of R minus P of L minus 1. So here also we have to use minus 1. And again here what we have to do is we have to find, okay, we have to find the maximum minimum. Okay, now uh, that is all. For result prefix of 0, for prefix on 1 it will be changing o minus 1 and all. Okay, now let's start coding. So I'll first copy the same code and we'll do the modification in that. Now here I'll use what, 2 prefix of 0, long prefix of 1. So this is one of the approach. There are different approaches. Prefix of 0 is equal to new long and prefix of 1, it will be also same. Now what we have to do is we have to calculate. Okay, what we'll do, for int 0 z starts from z to z should be less than or equal to 0, number of 0, and z plus plus for int o is equal to 0, o less than or equal to 1, o plus plus. Here what we will do is, let's take in not int long where 1 is equal to, solve this z comma o comma limit and false. So here if you see, here what we do is we send false. Okay, so we will consider this for our 0, and long var 2 is equal to solve z comma o comma limit comma true. One will be for that, one is for that. Now how we calculate prefix is, as I explained, this formula I minus 1. So what we will do is we will check. So prefix 0 of z and o, it will be what, if my z is greater than 0, if my z is greater than 0, then prefix of 0 of z minus 1 of o, else 0 plus, okay, plus what, plus var 1. Now let's use something, yeah, this one. Okay, so if I have the previous one, then we can use that and plus. Now same we will calculate for this one, prefix of 1. Here I'll use the this and minus 1, and here we'll use var 2. Okay, now we have calculate prefix. Now the part is we have to use here, okay, instead of this. So let's do, what we'll do is, let's take int left. What will be the left is, here we have left and right now. Left will be this So what we'll do, mat dot max of 0 comma zeros left minus 1, not minus 1, minus limit, int r is equal to only zeros left minus 1. So that is z minus 1 and z minus limit. Yeah. So if my r is greater than or equal to 0, then only we are going to say this. Okay. What we are going to do is, my result will be what? Prefix of 0 of zeros. It will be from right to left. So r, this will be o minus prefix. Here we have to check if my L is greater than 0. Okay, if it is greater than 0, if my L is greater than 0, then only we can use this. Okay, what? Prefix of 0 of L minus 1, because as here we have seen Z here L minus 1. Okay, so L minus 1 of O, else just use 0. So that is for the first element you can consider. Yeah, now also we have to use the mod, so let's use the mod here, percent mod, and also we can use this plus mod. Okay, same way we have to use, instead of this for loop, it will be ones left, and not here, it is not O. Okay, I mistakenly did that, it is ones left. So this is somewhere, yeah, this is ones left. Okay, now here this is ones left, no, not here, we won't be using. Oh yeah, now here we'll use zeros left. Now instead of this we will use the same in reverse. So we already calculated this, so we are just using here it. Okay, r, yeah, correct. Yeah, and that's it. So let's run this. Other than this, the code was the same, matlab similar. Only we optimized. Yeah, we are getting something wrong. Okay. So we have L. Here we did correctly. First we calculated everything. Yes, I did mistake here. I think here also, I'm not sure. Yes, here also. Why we are storing in prefix 1, right? Why, if we are going to use the same? Yes, yeah, I think it should be good now. Yes. Now let's submit this solution. So see, this is a way to solve a question. There are different ways to solve question. So if you see, it is accepted. So in this video we have seen the recursive approach. So how from this solution, okay, from the yesterday's solution, in yesterday's video we went from recursion to this memoization. Now today we have optimized it as due to constraint, okay, changes. So if you see 10 raised to 3, so before it was, the time complexity was 0 into 1 into limit. Okay, so now it will be 0 into 1 into 1. Okay, that means this 0 into this 1 into number 1. Okay, so yeah, thank you so much for watching this video. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated. Thank you.